Before your feet touch the floor in the morning, your thumb has already found the screen. You don't remember choosing to do it. It just happens, the same way breathing happens, the same way blinking happens. Why does a slab of glass and metal have that kind of pull over a grown adult who has bills to pay and decisions to make? The easy answer is that you lack willpower. You tell yourself you're undisciplined, distracted, maybe even a little addicted. But the real answer is far stranger than that. What pulls your hand toward the screen isn't a personal failure. It's a survival circuit older than agriculture, older than written language, and it has been studied, mapped, and quietly engineered by people who understood it long before you ever thought to ask why you do it. To see where that circuit comes from, you have to go back to a laboratory in the 1950s where a psychologist named B.F. Skinner was teaching pigeons to peck at a lever. Skinner's setup was almost insultingly simple. A pigeon stood inside a box. It pecked a lever. Sometimes a pellet of food dropped down, and sometimes nothing happened at all. Skinner wanted to know which pattern of rewards produced the strongest, most persistent behavior. The answer surprised even him. Pigeons that got a pellet every single time they pecked lost interest fast. The reward was reliable, which made it forgettable. But pigeons rewarded unpredictably, on no fixed schedule, with no way to know which peck would pay off, pecked harder, longer, and more obsessively than any of the others. Skinner named this a variable ratio reinforcement schedule. You already know it by a different name. It's the operating principle behind every slot machine ever built. Now think about your phone for a second. Sometimes you unlock it and there's nothing waiting for you. Sometimes there's a message that changes your whole afternoon. You never know in advance which one it's going to be. That uncertainty isn't an accident of the design. It is the design. So why does not knowing feel stronger than knowing? The answer has less to do with reward than you'd expect, and more to do with anticipation. In the 1990s, a neuroscientist named Wolfram Schultz ran a set of experiments at the University of Cambridge that overturned a basic assumption about pleasure. Schultz recorded individual dopamine neurons in monkeys while the animals waited for a small reward, usually a drop of juice. The expectation was that dopamine would spike the moment the juice arrived. That isn't what the data showed. Dopamine spiked earlier, during the gap between expecting the reward and receiving it, in the window where the monkey didn't yet know for certain whether the juice was coming. Once the reward became fully predictable, that dopamine spike faded almost to nothing. The chemical most people associate with pleasure turned out to track something closer to uncertainty than satisfaction. Hold that finding next to your own hand reaching for your phone. You're rarely checking for one specific thing. You're checking for the unknown itself. Has anything changed since the last time you looked, 90 seconds ago? Is there something new? Your dopamine system isn't especially interested in the answer. It's interested in the fact that there is a question at all. This is where the story stops being about technology and starts being about your ancestors. Picture a small group of early humans standing at the edge of a clearing, tens of thousands of years before any of this. Most of the time, the tree line showed nothing unusual. But every so often, a shift in the brush meant food nearby, or a predator closing in, or both. The individuals who kept scanning, who treated each quiet moment as a question rather than an answer, tended to survive longer and pass on more of their genes than the ones who decided certainty wasn't worth the effort. Vigilance wasn't paranoia. It was simple math, run by evolution over hundreds of thousands of years. A heartbeat spent scanning cost almost nothing. A missed warning could cost everything. Across enough generations, that small asymmetry was reason enough to wire the habit in so deep that no one would ever have to consciously choose it again. That scanning instinct didn't switch off when humans built villages, then cities, then nations. It just lost its tree line. For most of history, it found smaller outlets instead. Gossip passed between neighbors. News shouted in a market square. Footsteps outside a door at night. Then, within the span of a single human lifetime, it found something built almost perfectly to satisfy it. A device that fits in your palm, refreshes endlessly, and never runs out of new information to scan for. Here's the detail that tends to land hardest. The people who designed the apps on your phone weren't guessing at any of this. Several early architects of major social platforms have openly described drawing directly from behavioral psychology and slot machine design while building features like pull to refresh and the infinite scroll feed. The same mechanics Skinner had already mapped out with pigeons decades earlier. They weren't inventing a new compulsion from scratch. They were translating an old one, the one sitting in your nervous system since before recorded history, into a format that fits in a pocket and never has to close. Even the small red badge sitting on an app icon was not a neutral choice. It echoes something gambling researchers call the near miss, the flicker of almost having won that keeps a slot machine player convinced the next pull is the one that pays off. A red dot promises that something is waiting without telling you what it is, and that single unanswered detail is often enough to make you open an app you had no real reason to open. The pull isn't only about new information arriving, it's also about what happens after you put something out into the world yourself. In 2016, a developmental psychologist named Lauren Sherman ran an experiment at UCLA's Brain Mapping Center, scanning the brains of teenagers while they used a private app built to look and feel like Instagram. Each participant viewed their own submitted photos, and each photo displayed a number of likes that the researchers had quietly assigned behind the scenes. When a teenager's photo showed a high number of likes, a brain region called the nucleus accumbens, the same reward hub Schultz had already mapped in his monkeys, lit up sharply. The teenagers weren't simply enjoying approval after the fact. Their reward circuitry was responding to the social proof itself, the sense that other people out there had noticed them in a way that closely resembled how it responds to food or money. Hold that finding next to the small number sitting beside your last post. That number isn't neutral either. It's a direct line into the same circuitry Sherman watched lighting up in her scanner, telling you, before you've even opened the app, that something out there involves you. So when you feel that pull toward the screen, the twist isn't that you're behaving strangely. The twist is that you're behaving exactly the way a healthy human nervous system is built to behave, faced with the most refined unpredictability machine ever constructed. What feels like a personal weakness is, underneath it, a very old strength, aimed at the wrong target. That mismatch comes with a cost, and the cost shows up somewhere most people never think to look: your attention itself. For more than 2 decades, an informatics researcher named Gloria Mark at the University of California, Irvine has tracked how long people can hold focus on a single screen before switching to something else. When she began measuring this in 2004, the average was about 2.5 minutes. By the early 2020s, after 5 separate studies replicated the same pattern using different methods, that number had fallen to roughly 47 seconds. Her research also turned up something that cuts even deeper than the number itself. Most of those switches weren't triggered by an outside notification at all. People were interrupting themselves, reaching for an app, opening a new tab, checking a feed, with no external prompt whatsoever. What does that tell you about where the urge is actually coming from? It isn't waiting for a buzz in your pocket to wake it up. It's already awake. It's the same ancient scanning circuit, quietly running its own question in the background, dozens of times an hour. Is there something out there you're missing right now? That question used to keep your ancestors alive at the edge of a forest. Today, it mostly keeps you scrolling through a feed that has no end and no real destination. Think about how this plays out across an ordinary day. You wake up and check before your eyes are even fully open. You glance down mid-conversation, not because anything urgent happened, but because the gap in the conversation felt like an opening worth scanning. You reach for it in line at a store, in the middle of a show you're actually enjoying, in bed at night long after you told yourself you'd put it down. None of those moments are really about the content on the screen. They're about a circuit built for survival, firing off the only signal it has ever known how to send. Across a single day, those small moments add up to something larger than any one of them looks on its own. A few seconds here, a minute there, repeated dozens of times, the way Mark's research suggests, doesn't only spend time. It spends the kind of sustained attention that real conversation, real rest, and real work all quietly depend on. You don't lose that attention all at once. You lose it 47 seconds at a time, hand it over without a fight to a circuit that has no idea it's living inside a smartphone instead of standing at the edge of a forest. None of this means you're powerless against it, but it does mean the usual advice: just put the phone down. Misunderstands what it's actually fighting. You aren't negotiating with laziness. You're negotiating with a circuit that helped your species survive ice ages, droughts, and predators for 250,000 years, and a circuit like that doesn't respond well to guilt. It responds to environment. Take the badge away, and the urge quiets down a little. Leave the phone in another room, and the scanning instinct, with nothing nearby left to scan, eventually settles on its own. Notice what happens the next time your hand drifts toward your phone with no real reason behind it. No message waiting. No task left to finish. Just a hand moving the way it has moved 1,000 times before, following instructions written into it long before there was anything called a notification. That moment was never really about the phone in your hand. Your thumb was never chasing a message, or a like, or a piece of news. It was always chasing the hunt. Thanks for watching. If you enjoyed this video, make sure to hit the like button, share it with others, and subscribe for more amazing content. See you in the next video.